Okay, I think you should be able to see my screen. Can you? Okay. So what we are going to learn today is stack. Like, what do you get by this particular word? Like, any idea like what is stack? Stack is something like something you put over here and another thing you put on the top of it and another thing you put on top of it, right? It can be stack of books, right? You have a book over here, you can have another book on top of it, you can have another book, like so. Like if these are all the books and you want to take out this particular book, can you do it directly? No. First you need to take out this book, then you need to pick up this book, then only you can pick this book, right? If you take out this book directly, all the books ever this particular book will fell, right?
Yeah.
So like this is what like the idea of a stack came from. Okay, so what we have over here is we have something where we insert the element from the top, another element from the top, and when we are deleting it, we cannot delete from anywhere. The only flexibility we have is top. We can insert from the top and delete from the top. Okay, all these operations you can do from the top only. For example, if we have 10, 5, 6, 15, 18, okay, these are the elements. So let's suppose we have a stack over here. If you want to insert this 10, it will go over here. Now, if we perform what is at the top of a stack, we will get top is equal to top. When we will query what is at the top of my stack, you will get 10, right? My top will be pointing over here. And now when we will inserting 5, what will happen? This 5 will get inserted over here. And now our top will start pointing to this. Okay. If we again query, what is my top? What it will return? 5, right? Great. Again, now what we will do? We will insert 6 again. 6 will get inserted over here. Again, our top will get updated to the new element. Now again, if we query what is at the top of our element, it will give us 6. Now let's suppose we stop over here. We have couple of elements to insert again. But now we will perform few delete operation. Like one delete operation. What will happen? Like in computer, you don't delete things. What you will do, you will just update the top pointer to the previous element, right? Now it gives kind of perception that 6 was deleted, right? You're not doing something kind of assigning 0 or deleting in memory. Just change the top pointer to below. Now whenever I will query what is my top, I will again get 5. So now if I want to insert next element 15, what it will happen? This particular 6 will get overwritten and it will the value it will contain is 15 now. And my top will be pointing over there only. Okay. Got the point? Now again,
Yes, yes.
if we again want to insert 18, what it will do? Like in terms of programming, what we do? we first update the top pointer and then insert the value over there. Okay, so this is our stack, and if you want to delete, we can delete. For the first delete operation, this 18 will get wiped out, top will be over here. If we perform the same operation again, this 15 will get deleted, top will be pointing over here. Again, if we perform the delete operation, this 5 will also get deleted, top will be pointing to the 10. If you again do the delete operation, what will happen? The delete will be gone and a top will be pointing to the -1, kind of like if you are using array.
Mm-hmm.
If you again try to delete it, what will what say this particular situation, like underflow.
Mm-hmm.
Underflow, like this particular element, there is no element to delete, that's why you are getting condition as underflow. Same if you are at your capacity, like your stack can handle only 10 elements and you are trying to insert 11th element. What will you call that situation? Overflow.
Okay.
Okay, when you have no elements to delete and still you are trying to delete, what you say? Underflow. If you are at your capacity and still you are trying to insert some element, you will call that situation as overflow.
Mm-hmm.
There are multiple ways to implement. Like first way to implement, let's talk about the implementation. Okay, first is using array. In when we are trying to implement stack using array, what do? We define a fixed size of array and we use it as a stack, right? Just taking the top pointer and moving it back and forth, right?
Mm-hmm.
Because we are using array, so the size is fixed. Size is fixed, right? So all the situation like underflow and overflow arises in this particular implementation. Okay, so there is another implementation using linked list. Any idea how can get this stack behavior using linked list? Anyone? Like,
We will in first take the first element, and point it next to the next element. But if there is a single element, we will make it as null.
make is that null? No, I'm talking about
Yeah.
how we can actually make a linked list so that all the operations that we perform on the linked list
Mm.
will mimic the behavior of this stack only. Is there anything? For example, if we take another example, like
Oh, okay.
I
Use it. Okay, I got it. Basically.
yeah, and few delete operation, again few delete operation, and then again I will try to insert 3, for example. What we have head pointer over here.
Mm-hmm.
Okay, it is pointing nowhere, right?
We will do it as when we want to do the delete operation, we need to go to the end. Like
Hmm.
we will traverse till the node is null and return the last value. Right. That will be our delete operation. For the peak operation also, it will be the same. And yeah, that's it,
Yeah,
right?
you can do that. You can do that.
Yeah,
All the
here
operation.
we could delete the null. The last pointer means the null operator. The
Hmm,
node which is pointing to null, we could delete that and we could update the previous one
hmm.
with null.
so that it will be the top,
Hmm.
and then so if we travel still end again, the null operator will be on the 3. So
Hmm.
when null, that part will be removed, and the null operator, the pointer of second node will be pointing towards null again.
Hmm.
Then if we add a new node 3, then the pointer of 2 will be pointing towards 3 and 3 will be pointing towards null.
Okay. Whatever you are saying is correct, but there is a little flaw. Like start saying it, and I will be inserting all the element like this only. Like what I will do if I have like my head is currently at null, what I will do next?
So we'll create a new node, namely 1.
Okay, I have created one node, namely one.
We,
Then
head will be pointing towards 1
head is pointing to one now.
and 1 is pointing towards null.
Okay, one is pointing to null. Great. Now,
So this is top.
yeah, this is.
Then after 1 is pointing towards 2,
Mhm. Yeah, keep saying. I'm listening.
1 will be pointing towards 2 and 2 will be pointing towards head. As 2 has a pointer null, head will be traversing towards 2.
Yeah. Now, when we are inserting two, what we will do is we will again create a two, a new node named two. Then what we will do?
Head. 1 will be pointing towards 2.
One will be pointing towards two, you are saying.
Yeah.
Okay.
And null will be updated. 2 will be pointing towards null.
Okay, you are saying now this will be pointing to null, right?
And head will travel to where the null is.
And head will be here.
Yeah.
Okay. You will come here. Like if you remove the head from here, right? If you remove the head from here, you came here, right?
Yeah.
Now how you are going to one again?
Means
Like
if
because
we remove, if we delete the 2
Mhm.
and if we update 1 pointing towards null again, means
Mhm.
2 previous node is equal to null.
Mhm.
Head will be pointing towards 1
Mhm.
and it will be the top of the list.
Okay, so you are what I got from your explanation is you will have head over here pointing to something, and all the nodes you will be adding like this, right? And you will be deleting from here.
Yeah.
Yeah. Okay. Yeah, this is correct, but like there is a better way to approach all this, because if you have head over here and you are performing the operation on its tail all the way, like you are for any operation you will traverse the entire linked list over here to even perform new insertion or to perform new deletion, right? So even like insert, we don't call it insert, like if we the standard terms are called push means inserting element, and pop for deleting element, right? So in your approach you will traverse the entire length of linked list. If the length is like of n size, it will be having big of n time complexity, right? Again, if you are doing the pop operation for from the back, you will again traverse the entire linked list to go back, and again you are doing the big of n work, right? Can be can be can we think something, and we can just do everything at
Yes,
big of.
yes, yes.
We
Like basically
travel.
what we can do is,
Hmm,
one like first element came, okay, it is pointing to null, correct?
yeah, just
The second,
hmm,
second when the second element will come, we
hmm,
will point it to one, and one will point to null. Okay.
Hmm.
So in this way, it will be a stack operation, because at the head we will get the peak element as well as the delete one also.
Exactly. All these operations were like insertion. At the end, it was an deletion at end. So if you are doing operation at one end only, why to go for the expensive end, like expensive operation? Like in end in the English is like expensive edge, right?
Hmm. Yes.
Means corner, you can say, or like uh so if you want to do anything at this location, na, you will have to traverse all the way an operation. Can you, like, your head is pointing over here? Instead of doing this everything over here, do everything over here as well, right? You can directly get this thing just in O of 1, right?
Yes.
Getting the point? For example, let's take the same example over here as well. We can create one more. Hmm. For example, we have 1, 2, 3, 4, and 5. Some delete operation and other delete operation, and again we can insert 9. Okay. Our head is initially pointing at null, right? We have to insert 1. What we will do is we will create let's start from this end. Hmm. I will create 1 over here, and I will attach this 1 with the head, right? Getting the point? Like, is it clear? I'm creating a node and pointing it by the head because there is only one node. Hello, am I audible?
Yeah, you're audible.
Hmm. Now, what when I'm inserting 2, my new element is 2, right? The only information I care about at this particular point is 2. Okay, I don't care whatever is inside my linked list was before. I have added new element 2. Now at the top of my stack is 2, right? What we can do is we can create a new element 2, and the next of 2 would be pointing wherever the head was pointing. So it will again start pointing to a 2, and now I will update my head to where? To my new node, right? If you again visualize the same thing by the array method over here, what was happening? Initially 1 was there, right? Top was here.
Yes.
When I inserted my new node, 2 came over here, and now my new top became 2, and I can directly access my top from here. Just head dot val is my top, right? Is it clear?
Yes. Yes.
Now again, if I want to insert 3, what I will do is, let's see in array, if we insert 3, my top will be here, right? All these top are like useless from here, right? If we again try to visualize it into the linked list, what will happen? My 3 will be here. Wherever my head is pointing, point the new node to that location. So it will start pointing to the 2, and my head will start pointing to the new location, right?
Yes.
Getting the point? Instead of
Yes.
doing everything from the back, you can do the things from the front, right? If we
Yes.
again come here, what will happen in our array? 4 will be over here, and the head will move to here, Same again, what we will do, like if we try to mimic the same behavior in our linked list, we will again create a node 4. We will point the next of 4 wherever the head is currently pointing, and we will update the head to the new node here, right? Now we have 5. Same, what will happen? We have 5. We will insert 5 over here, and our new top will become what? 5, right? Again, we try to mimic the same behavior over here. Sorry, yeah. 5 will be over here. Again, the same thing, wherever the head is pointing right now, point to the same location. Like the new node next will point to the same location. And again, I will update the head to my new node over here. Right? Got everyone, like everything is clear till here, till this point?
Yes, yes.
Now, if we talk about the deletion part, what we do in our deletion, we just decrement the pointer, right? Like my top will start pointing to the previous element. So here I'm assuming my new element is wiped out, right? Is this clear? Like why I'm just deleting operation means decrementing the pointer and not doing any actual thing within this.
Mhm.
Is this clear? Like, is this clear? Is there any doubt in this particular
Nope.
operation?
Nope.
Yeah. So if you see over here, what I did, I just decremented my top pointer from top to, like one step back, and
Mm.
whatever my next value was, second value was, I started pointing to that, right? Same here, if I
Yes,
wanted
yes.
to delete 5, what should I do? My head should be pointing to this, right?
Mm. Yes.
How can I get this value? Like whatever the value head dot next is there, now you should point to
Will
this.
become the head.
Yeah, exactly. So this link will be there, but we will break this link. This link will be broken, and my head will start pointing to 4, right? This is what happened actually when you are trying to code. You can handle this case like deleting the node and do whatever you want, but in general, we don't do that. Like it's not a good practice, but while doing competitive programming or implementing things quickly, we just move the update the head pointer. Okay.
Mm.
So here also my top is pointing 4. Here also my top head is pointing 4, right? Again, what will happen if we again perform the delete operation? What will happen? This top will get decremented again. Now it will start pointing to 3, right? Same thing should also happen over here. Like this head should also start pointing to 3. What we will do, head, wherever head is pointing, update the value, like head equals to head dot next. So
Mm.
what it will do, it will just update whatever the value is over here to this thing, and it will start pointing to this, and this link will be broken, right? Here also my top is pointing to 3, and here also my head is pointing to 3. Either you can call it head or call it top. Okay, depends on what you call it.
Mm. Yes.
Again, if you're trying to insert 9, what will happen? Your top pointer get incremented
Mm.
over here, and wherever new position is, that will get overwritten. Sorry. This value get like y overwritten by the value 9, right? Now actually we have 9 over here. Same thing should also happen over here, right?
Mm.
So what we will do is we will create a node named 9. What we will do, wherever the head is pointing, point the next of the new node to there, right? And update the
Yep.
head to the new node. So my head will be pointing over here now, and I will just remove all the previous things, right? Is it the same thing that is here and here? My head is pointing to 9, right?
Yes.
My top is also pointing to 9. Is there any doubt between this thing and this thing?
No.
Change from means in coding, how do we change from 4? Means it is from 3 to 9.
From 3 to 9, this is what you will do. Where like my 9 knows where 3 where 3 is, right?
But how does head knows to go to 9 instead of 4 again?
Again, can you please repeat your question?
Means 9 is also pointing at 3
Hmm.
and 4 is also pointing at 3.
Yeah,
But how does the head knows to go to 9 instead of 4?
yeah, we will write the algorithm in such a way, like what we have done over here, right? Let's see. My head was pointing over here, right? When we were inserting 9, my head was pointing over here, right? Before we
Yeah,
inserted 9. What we done? We created new node, right? We created new node, entirely different node,
yeah,
and we attached the next of the new node wherever the head was pointing, right? It will start pointing to the to 3, right?
yeah,
And now if I know my head is right now pointing to 3, and I have created a new node 9, I have pointed it to the same location where head is pointing. This is my call it like T, my T node. What you can do? You can do head equals to T. Now this head will be pointing here, right? Did you got the point?
yeah, yeah.
Yeah. So no, no, no. Like if you still have doubt, just let me know. I will like
Means while adding new node, the name of the new node will be different. So rather the name of the new node will be different from the previous node so
hmm,
that we can point it to the new node directly.
yeah, not the name. It's actually address.
Address.
Actually, he's getting confused about that. It's not getting deleted now. He's getting confused there.
Yeah,
If
Yeah,
you will tell now that it is getting deleted, then
yeah.
he will.
When you are like updating the header pointer, assume this has deleted, but this remains there. If you somehow store the address and move the header pointer over here, still you can traverse the linked list from here. So that's why I whatever is happening actually in the computer, I'm showing that. You can delete it if you want. Okay. Okay. So like, do you want the code as well? Like, or would you like to try on your? Just give me a second. Yeah. So Do you want the code, or you guys wanted to try on your own? Hello, am I audible?
Yes, sir.
Yeah.
I can code actually.
What about like sorry, not Akash, Karthik? No, if you want the code, just let me know. I will write it over here.
Yeah, I will try the code. If I
Okay.
had a doubt, I will just ping you.
Okay. Like, let me write a little bit of pseudocode so that you get some idea. Like, uh, hmm. Like, what you can do is make a top pointer initially at null. Okay, and you will have like kind of in push function, uh, like one function. I'm not writing actual code. I'm just writing pseudocode. It will be push. What it will take the top pointer and a value. Okay, what you will do in this particular thing is we create a temporary node. Sorry, temporary node by this given value. Okay, and then what you will do is you will point t of next wherever my top is pointing right now, and then what you will do, top equals to t. Like, this is what your push function looks like. What let's see what is actually happening. You have a linked list, you have a top over here, either call it head or top. You have one. Sorry, you need to check over here as well if top is null. Okay, then handle that case, like just get a single node and attach it to the top. Try it on your own. I'm just writing the pseudocode, not the entire code. So what will happen? I will create a new node. If I'm inserting 2 over here, this will create a new node with value 2. Now what I'm doing, here my t is pointing. Now what I'm doing is t dot next. I will point t dot next to the top, where top is pointing at 1. So this will also start pointing to at 1, right? And next what I will do, I will update the top pointer wherever my t is there. So this top will come over here and start pointing to this node. Came here, right?
Hmm.
Got this push function? Got the idea?
Yes.
Yeah.
And now for the pop operation, you will have a function. You will have a pop operation over here. What you will get? You will get top. Like, pop is much easier than push. What you will do? Check. I can write it. If top double equals to null, what do you call this situation?
Out.
Underflow,
Stack
Oh,
is
right?
empty.
underflow.
The stack is empty under.
Yeah, underflow. So return -1 depends on question, whatever it is saying. Else, like in some scenarios, you need to return the value, whatever you are popping out. But it totally depends on how you need to implement it, right? So either you can return the element that you have popped it or just delete it. Like if it is there, then return -1. Else what you can do? What you will do? What you were doing over here? You were just decrementing the things, right? While deleting it.
Is equal to t next.
Yeah, exactly. What you will do? Top equals
Top
to
is equal to
top of
top
next.
next.
Yeah. If you want to return, just save it and return it. Otherwise, yeah, this is it. This is the push code and this is the pop code. Okay. Any doubt? Logic, code or working? What is stack, how it works, and how we implement it? Any doubt in all these? So till here, I'm assuming you get the idea of stack, right? Okay, I'm giving you few elements like 1, 2, 3, delete operation, 7, then delete, then 8, then delete, and then 9 and 10. Tell me what will be the output? What will be into the stack after this all the operation is done? Take your time and tell me the answer.
Sorry, what is the question?
You have these elements 1, 2, 3,
9 and
and
10.
yeah, then you need to perform delete operation, then again delete operation. Then you have insert 7 again, then again need to perform delete operation, then again you need to
And
insert
9 and 10 will be the final.
like what you were saying, Karthik.
In stack 1, 9 and 10 will be the
Okay.
3.
And what about Suham?
Yeah, telling just a second. Yeah, same.
Okay.
Correct.
1, 9 and 10.
Yeah.
And if we see here, this will be matched and this will be matched. They will be later, they will be later. Yeah. 1, 9 and 10. Okay. This is right. So you got the idea, right? Let's see some question. Now, till here was boring part, knowing the data structure, how to implement it, and how we are going to code it. Now, actual applications. Let's see few questions, how we can do it. I have one question over here. Okay, we can read it out and let's see what is happening. What is given over here? You are given a string S consisting of lowercase English letters, right? It is given that you will be given a string. It will contain only lowercase, so you don't need to handle lots of conditions like capital, special, or everything. Only it has lowercase. A duplicate removal consists of choosing two adjacent and equal letter, right? What it is saying, a duplicate removal consists of choosing two adjacent and equal. Means choose two adjacent equal element and remove it. And remove them, right?
Yes.
And we repeatedly do this operation until we can no longer find any two duplicate element adjacent, right? And return the final string. I have done this question long back. So anyway, let's see this example and we can discuss over here. How we are going to do this? Just talk about any normal approach first. Don't go for stack right away. How you are going to approach this problem? Like what question is saying? Whatever duplicate adjacents are there, just remove them. Like after removing this, you will get A, and C and A. Again, you have some duplicates adjacent, right? And again, you need to do delete it, and you will become it will only you will only get C and A, right? So you need to do until you cannot remove any duplicates. So how you are going to do this question?
First take an empty string and we will insert. First we'll take an empty string and we'll insert that. After inserting, we'll check for every element. Means if first element in an array, zero of first element, zeroth element is equal to one element, then traverse to third element and remove 0 and 1. Else means I mean 0 of I is equal to 0 a. If string is a of I is equal to a of j. Move top means point a element called t to 0 of 1.
Okay, let's call it as S. If
Yes.
somewhere S of I,
S of I is equal to S of j.
not J, should be I plus 1, right?
I
Because
plus 1, yeah. Okay.
they should be adjacent.
I plus 1. Then
You can skip these, right? You can skip this.
we can skip this and we could go to the next element, which is I plus 2.
Yeah, you totally can do that. So like until you need to like do while like
While s.
not while s, like while operation was performed. Okay, while operation is performed, skip these, and like you can code like somehow what you will do wherever you find two adjacent equal, store all these and all these into here by removing these. Because operation are performed, you get again do this. If somewhere you find something equal, you will remove them again, and again by removing them you will get something over here. Because here also operation are performed, you will again do the same thing, and like keep doing this until you will find that no operation will perform over here and here, and you will return this thing. In this way you can do this. But
we'll be having means we could take two while loops, in which one the first while loop will be until everything is over. The second while loop will be going to the string before updating. Means we could do like, can we do like that?
for example, if we take the above example, it was A, B, B, A, C, A, right?
ACA.
So what I mean to say is, if we find any place where ith is same as I plus 1,
I plus 1,
we will skip these two, right? And take
and we
all.
will print everything remaining A, C, C, A.
Yeah. Now because operation was performed over here, we again need to do the same thing over here. There can be some new element that after deleting they might have come together, right? So yeah, here again we saw some condition. So we will skip those and we will print the remaining CA. Again we will try over here. So none of
So can
are
we
equal.
write the code like this? If I S of I is equal to S of I plus 1, we'll just leave it. Else in else condition, we'll be printing S of I. Print S of I.
Yeah, you don't need to print anything. You just need to calculate thing and just return it. So yeah, whatever your logic is saying, try that code, and like this is kind of brute force approach. Okay, the approach we are discussing over here is kind of brute force. We are just checking if there is any pair, we will skip those pair and generate new string. And because some pair were skipped in the previous step, we will again check, like after skipping all those elements, are there any new pair forming? If there is new pair are appearing, we will again remove all those pair, and we will see if like until how far we can remove, how far we can skip all the pairs, right?
ఆగిపోయింది. ఆగిపోయింది. ఏముండే ఏది ఇచ్చి రెండేసి రెండు కార్తీక్ అని పేరు పెట్టి నాకు అర్థం కాదు అసలు. ఎస్కే ఫైనల్స్ లోకి వెళ్ళింది. ఎందుకు వెళ్ళిందిరా అంటే నేను సిఎస్కే ఫైనాన్స్ లోకి వెళ్ళిందిరా అని సమీర్ గారు మెసేజ్ పెడితే ఊరికి వెళ్ళింది అనుకున్నావా, ఇంట్లో కూర్చొని చేత పడి చేసి మందు పెడితే వెళ్ళిందిరా అని పెట్టా మెసేజ్. అరే నువ్వు సిఎస్కే ఫ్యాన్ రా అంటే
Can you see my screen? Hello, Karthik.
I cannot see your screen.
Okay. Someone broke the Wi-Fi adapter and everything is messed up. Anyway, we are here again. Okay, so where we were talking about like, the brute force approach, right? Is recording is still going on? Yeah, it is. So what we will do over here, we will loop through the entire string. Wherever we will find the adjacent element are same, what we will do, we will just take the remaining elements and skip the same element like A, C, A. Here BB was, we skipped all those, right? And whenever we get this, like if I is like the element at I is same as element at I plus 1, okay, we'll mark like skip and make it like flag equals to true, right? Something like this. Getting the point? Hello? Getting the point, like wherever these are equal, just skip those and store all the remaining, right? Like, is there any doubt over here? Like, are you thinking how we are going to do this in terms of code?
I'm not understanding. How do we write a code?
Okay, let me write a code for you then. Okay, let's see. Okay, over here we will have given a function, like we need to return a string. We will be write a function and also given what the string that we need to perform some action as over here. Then what we will do is I will create a temporary string, right? initially it will be empty, and a flag, boolean flag. Initially it will be at true. Like there are some operation to perform. Right? Now, while my flag is true, we will do something. Right? What I will do over here is, this is our closing thing. After all the operation, I will just return my t. Or we will see what we need to return. I'm not returning anything from here as of now. What I will do, I will mark this flag as false. Means I'm inside my loop now. I will try to remove few pairs, and if those pairs are removed, if some pairs are removed, then what I will do, I will again mark this flag as true inside that loop. Let's see how we can do that. For I will do like I equals to 1, I less than s dot size. Okay, I plus plus. Let's remove these for now. Like if at some point of time my I, s of I is same as s of I minus 1, right? Because I'm starting from 1, I can go one step back, so it will not give me any indentation error, right? Getting the point over here, this thing. So what I will do over here is, my s will become, I will update my s as like s dot substring from 0 to, I need to remove I as well, right? Then I will store just I plus s dot substring. I will start from I plus 1. And I will, like, if we pass on the index, it will just go from I plus 1 to all the way. And again, because we have updated something, I will mark flag is equals to true. I don't need this temporary string now, because I have wrote the code in such a way. At the end, when my loop will break, I will come out of if, out of for, out of while, and I will return s and my function close. Like, is it clear to you? What I'm doing over here is, let me try run for you.
S is equal to s dot the substring from 0 to I and from I plus 1 substring. Means I
not,
plus 1.
not 0 to I. It's saying substring starts from 0th index and take the length I, right? So if you have A, B, B, A, C over here. So at this particular point, I will be here, right? I will comparing I by I minus 1. This is what I'm doing, I by I minus 1, right? Getting the point. But
Yeah.
I will be here, I mean starting from here. When I will be here, I will comparing the one character back. So if they are matching, if this condition is true, what I will do, I need to skip this, right?
Yeah.
So I will take this remaining substring and this remaining substring and and I will concatenate them. What I will get? A and C. Okay. So if we take from 0, here I'm at 2. So it should be I minus 1. Okay. I minus 1. So means from 0, take one length substring, that is A itself. From 0, A length substring A itself. So this is this part. And when you are getting I plus 1 to the completed string from I plus 1. So from here to here, this is the second part. So when we are doing this, it will I can write the code that will be much clear to you, right? Let me try the brute forcing. It will not get accepted, but anyway, we can try it. What we have done initially, I have taken a Boolean flag, right? Initially at true. Getting the point over here. Hello. And then what we were doing, while my flag is true. So write the same thing. While my flag is true, what we will do is we will loop it. Like I will mark a flag as false over here. This is what I have done in the code. Just I entered into the loop. I will mark my flag as false. After that, I will apply a loop for int I equal to 1, I less than s dot size, I plus plus. I will just check if my s of I is same as s of I minus 1, right? This is what I have done. S of I is same as S of I minus 1. Like this is, if this is less intuitive, I can write like this. S of I minus 1 is same as S of I. Then what you will do is you are just doing S dot sub string 0 to I minus 1 plus S dot sub string I plus 1 to all the way back, and also you will mark a flag as 2. It should be flag, not bulk. Until I'm doing this, keep moving, and at the end just return your S. Let's see if it is able to pass few of the test cases. It's expecting something. I have commented out something and it's not matching now. Okay. Okay, got the point. If we submitted, this is 10 to power 5, so it will get time limit exceeded. But yeah, if you see, this logic is correct. We were able to solve 104 test cases out of 106 test cases. Now you got the logic, how we are going to convert this into the code. Hello.
So when if we get the answer right,
Yeah, we
the
got
test
the
cases should be correct.
again, like you're not
Every
audible
text.
properly, right? Hello.
Yeah, yeah.
Yeah, you were saying something.
Even if we are getting right answer, means the code runs and we are getting the expected output, we should pass every test case to complete the question.
You should pass each test case. So, like, this is the correct answer. We are not getting any wrong answer kind of thing. We are getting, because this is a brute force, so we are getting memory limit exceed or time limit exceed. Okay. As you can see, it is able to pass 104 question. We will see how we can optimize this thing so that we can pass all the test cases within the given constraint, right? Like better approach. So this what we were doing in the first approach. It was looping through all the things and then skipping something and then storing the remaining. So we are doing like for the entire string, we might remove this thing and it will be shortened by 2 length. Again, it will be some like any 2 character will be removed. It will be shortened by 2 step. Again 2, again 2, again 2, and some like at some point of time, we will get our answer. So the time complexity of this algorithm is na big O of n square, right? Do you know this notation? Hello.
Can you hear me?
Yeah, I can hear you.
Echo notation.
Yeah, big O notation. So we were getting MLE or TLE because we are not writing any optimal approach. It was kind of brute force approach. Let's talk about better approach. We were using some data structure that is stack that we studied. Can we use stack somehow and get the answer? Can you imagine this thing? A, B, B, A, C, A is here. Can you use stack somehow in this and get the answer just in one pass?
We push the elements.
Yeah, try random thing. Just push the element, pop the element, check the condition. Keep doing that and see if you can get the answer.
If we push the stack like this improperly, like it means for if top, while we increment top, like we'll be pushing A, B, B will be top, and again if we push B, then both elements will be same. So top next is equal to same value as top. Both will be deleted. Then A will be there. A will be become top as we deleted B before, which is the previous top. So A next will be means top next will be again A. So A will be deleted. Then C will be inserted. Then C and A will be the final output.
Yeah, great.
Is that right?
You got the logic. That is what actually we are going to do. What we will do over here is we will create our stack, and right now we are pointing at A, right? And sorry, and my stack is empty. So the only thing we can do is just push A, right? We can't do anything as of now because our stack itself is empty, right? Now we have inserted the A, will we start pointing to B? We will move to next character, right? Okay. Now we will compare wherever we are pointing, is same as the top or not? Is my B is equals to A? No, this is not the case. Then what I will do? I will insert the my character wherever I am pointing, and I will increment the top as well. It will move to over here, and this will be moving to over here. Now we will check is like wherever my this is my new character, and I will check whether my top is same as my pointing character. Yeah, it is. B is same as B. So what I will do, I will skip this particular character and pop one character from the stack. So kind of removing that pair. So what I will do, I will skip this pair over here, and I will be popping the element means decrementing the top pointer, right? Again, I will check like is it again equal, like wherever I'm pointing is same as my at top of a stack. Yeah, A is same as A. Again do the same, skip this character and pop this as well. Kind of my stack become empty. Now what I will do, I'm pointing to C. My stack is empty because I'm pointing at invalid location. So yeah, insert it. I will come to here and I will override this A by C, and I will move the pointer to at this location. Again, I will check whether wherever I'm pointing over here is same as my top of stack. No, C is not same as A. So what I will do, I will insert this as well. So what will happen? My top pointer will get incremented. My this value get overwritten by A. And I will move to the next location. So I found that I have completed my string. So whatever is in my stack is my answer, but in the opposite direction. So if you pop A, you will get A. Now you will pop C, you will get C. This in the reverse direction. What you will do, you will just reverse everything. You will get C and A. So this is my answer. Got the point?
Did not get the A and C part. What is the reversing stack?
So if you see, the remaining elements in the stack was A and C, right?
Yes.
So if you, what you can do, you can only do operation at the top. So if you pop the first element, what you will get, you will get A, right? Because A was at the top. Getting the point? Hello. Like if you
Yeah, I'm
for the
getting the
first
point.
time, you will you will get A. Now your top will be pointing to C. Again, you will pop, you will get C. So you got in this order, you got A and then C. But the answer will be in the opposite direction, like in the reverse direction. First, you need to get the C and then you need to get the A, because this is how the stack work. You push the things in from the top, and you start popping from the top itself. So things get reverse out. So just pop all the elements and store it somewhere and reverse everything. You will get your answer, right? This is how your efficient solution will look like. So yeah, let's comment this out and try to implement it. Like, do you want the code, or you like to try on your own? I can write the code as well, but it would be better if you try to implement the stack and then try to do this thing. And you don't need to implement a stack, just use vector and you can somehow mimic the same behavior as a stack. Would you like to try it on your own, or do I need to write the code as well?
I don't know what vector means.
Hmm?
I don't know what vector means. What
Okay.
is
You can use array.
Okay.
You can
Okay.
use
Okay.
array. Just use an array of same length. Whenever you are like initially your I will be at -1. Okay. When you are inserting the letter, increase the I, store the element at that location. And when you are deleting the element, just decrease the I. Right? This is what we talk all about, the implementation of stack in here. Here, if you say at this part here. So try to implement the stack and then you will be able to solve this question easily.
Can you send me the lead code link of this problem?
Sure. I've shared it. There is another question I wanted to cover, but I don't think that I would be able to cover in this particular session. So try this particular question, get the intuition. If you still face any problem, just let me know in the chat or on my WhatsApp. I will explain it again. And then we will see an interesting question like how we check balanced parenthesis. We will be given an expression of some random parenthesis and we will check whether all of them are balanced or not. And like stacks are really useful. If I start talking about some like you are doing BTech, right? Hello.
Yes, I'm doing it.
So you might have heard about postfix notation.
Not that I remember.
Yeah, postfix or reverse pollination. We use this tag. We will discuss how we can convert given expression from infix to postfix. We will see all those. First, we need to see how we check this particular thing, and then we can see all those things. I think we are done for today. We will discuss all these things in the next session. Okay. Any question, any doubt that you would like to share? I'm stopping the recording.